Before you begin with item bias, make sure you understand construct bias and predictive bias. We first compare the groups for the same construct when we investigate item bias. We want to see whether the scores of the two groups are similar, or we ask, do these groups manifest different behavioral patterns in respect to these test items or questions? So in the previous video, I went over cross-cultural comparisons using different language versions of the test and the items. And I said that individuals with the same or similar standing on a construct but belonging to different groups should obtain the same or similar scores. Okay, so let's discuss bias and equivalence at the item level. Okay, so what is diff? It's a better word for item bias. So in addition to the construct, items themselves can be the source of bias. So item bias, also known as differential item functioning, is a generic name for all disturbances at the item level. Okay, so what do we mean when we talk about groups, subgroups, and group memberships? Okay, we categorize people in different SES groups: gender, ages, races, psychiatric illnesses, top, middle, line management, and so on. Okay, so diff merely indicates that an item functions differently for those groups. And statistical methods for detecting diff are discussed on page 91, and IRT is one of them. Okay, item response theory. So with these methods, we are able to compare between two groups and determine whether any bias exists, and items flagged need to be further investigated. Is that item too difficult, or is it too easy for that particular group? How did that group interpret that item, and so on? So to recap, an item is biased if persons of equal ability but from different groups do not have the same chance to answer the item correctly. And this is based on item response theory, IRT. Okay, next slide. So what is IRT? Okay, so it's a test theory used to develop tests items to analyze data. Okay, so we detect diff by using IRT. In order for us to locate item bias, we use ICC method, the item characteristic curve. Okay, this relationship is represented by the ICC on page 92. So IRT and ICC allow us to analyze each item separately, and we are able to see both the discriminating power and the difficulty level of the item, much like classical test theory, but IRT does it more accurately. Okay, we analyze the relationships between the ability, which is the latent trait of a person, and his or her response to easy or difficult items. We can do this by using ICC, and this shows the relationship between the person's position on the trait being measured, okay, their ability level, and the probability that he or she will get a correct score on that item. So this is estimated by the proportion of people who got that item right, and that is shown on the y-axis. Okay, also, IRT provides a test of item equivalence across groups. So we can test whether an item is behaving differently for Asian, coloreds, blacks, whites, for females, and for males. Okay, so it is possible to draw an item characteristic curve for the same item for different subgroups. Okay, how fascinating is that, hey? So these curves indicate how each item functions at various ability levels for different subgroups. Okay, and diff is indicated by the area between the curves. You don't have to know these the technicalities behind IRT and diff. You just have to define them and then state why we use it and give an example as above. Okay. Now, you need to also mention the disadvantages. Large samples are required, and it is costly software, okay, to buy. So what I want you to do is read pages 92 and 93 and have a look at the curves in figure 7.1 and 7.2. And you'll see that the first figure is comparing two questions or two items in a test. We can see that item 2 is a flat line, which means that there's very little discriminatory power, and it's a difficult question. Item 1 is moderately difficult and is highly discriminating, which means that more people in the top upper group answered correctly. The steeper the slope, the higher the discriminating power. So you can see we can compare two questions. Okay, and if one question behaves differently, then we tweak it or chuck it out. Right. If you don't know what discriminatory power and item difficulty mean, please go over classical test theory. Right. In figure 7.2, we're comparing two groups who answered an item. So let's say in this case we're comparing male and female qualified engineers answering a particular question. Okay, remember the ability levels of both male and female in this case are equal. Okay, so the ICC should be the same and the lines should overlap, and clearly you can see they're not. And this indicates that the item is functioning differently for each group. I hope this makes sense to you now. Group 2, okay, obtained a lower test score, so the construct that we're measuring is not measuring well for Group 2. Perhaps unfamiliar, inappropriate, or ambiguous language or concepts, or even test speed, or unfamiliar question format was used. That's what the book says. What do we do in this case? We review the question, tweak it, or chuck it out. Hope this has helped you.